everyone, good afternoon. So this is Sachin sir again. Okay, so here we are being here in the YouTube channel of the Sri Chaitanya Educational Institution. So guys, again we are going to start with the same topic as we have been left it in the previous year questions we were doing. Okay, so I hope you all are being very excited for this next one, because I told you I will be taking the concepts also again along with the questions. Okay, so today I bring this some concepts, that is the most, as you have seen the description and the topic also, that is the top 10 physics concepts and all. Okay guys, so basically I'll be added more of it instead of the 10, but yeah, top 10 will be there. So I'll be giving you the complete form of the revision. So whether if you are preparing for the score for the Olympiad or for your school examinations also, this is the lecture, this is the session for you. Okay, so again, so we are from the Sri Chaitanya Education Institution, and we are doing what? We are doing the practice of score examination, as you can see it right now. Yeah, that is a series of the score which is going alive for what? For your better understanding, for getting the good marks, for getting the high ranking in it, and getting the good and the 100% scholarship along with the gadgets and all. Okay everyone, so this is the score and this is me Sachin. So let's start with the physics 1 part of the grade 7. Okay everyone, yes, so just don't forget the dates are, I have been put it here, that is 28th of September and 12th of October. So remember, these dates are very important for you all, because for what you are preparing it if you don't know the dates. Okay, so dates are very important. Getting my point? Okay, so then let's come to the part. See why I'm just coming very faster with the part of it. We have lots of the things to discuss today. Okay, so here we go then, one by one. So the session outline, we all know the topics which has been coming in the grade 7 has been the motion, the time, the heat, the motion and the time. Just a second, let me, yes, the motion and the time, the heat, the electric current and its effect, the light, force of the 6th class, and work and energy from the grade 6. Okay, so I tried my all the things to be put it in the lecture. If anything will be left, you can just put it in the chat box. Okay, and I can take in the next session also in that. Okay, so let's talk about first about the electric current. First about the electric current and its effect. Let's talk about the electric current and its effect. Okay, see, one of the very important chapter also and the topic we can say. Okay, in this what we are going to study is the how the flow of electron is taking place, basic things, and basic terminology will give you the each and every part of the this chapter, whether you are being going for your school exam or you are being preparing for the same thing, that is what score we are doing it. Okay, so here we can see. So first of all, how this thing has been working. So that is an atom who is responsible for it, we all know. Yeah, an atom consists of the three things, that is the nucleus, the proton, neutron, and the electron. Basically this nucleus consists of the two things, as we all know. It consists of the proton and as well as it consists of neutron. So all of the mass of the atom is being concentrated at the center of it, and then this electron, which is negatively charged, this negatively charged, proton is positively charged, neutron is the neutral one, but it has the mass. It is a neutral but it has the mass, remember it, it is neutral but it has the mass. So this proton is positively charged, electron is negatively, neutron is neutral, and its orbit over which the electron is being moving. Okay, over which the electron is being moving. Clear? So what happened basically? Actually this proton, which is having the positive charge, have certain mass, that is 1.67 10 power minus 27 kilogram. See, the important part which is being required for us for the examination, that I'm going through it. Okay, then this electron, that is negative one electron, that has 9.1 into 10 power minus 31 kg. That is around 1838 times on an average, approx. That is the one. Okay, so this proton, we can say, is around 1838 times heavier than electron, and that is the reason the current is flow because of the flow of the electron, not because of the protons. Okay, so that's why we call it as a convectional current direction, that is moving from the positive to negative, but the electrons goes from negative to positive. Okay. Okay, I hope so this was being clear. Then we have the neutron. Neutron is slightly heavier. Neutron is slightly heavier than this proton. Okay, remember, this is for proton and this is for electron. Okay, so what happens in the circuit when you connect any source like a battery or a cell? So in that, say, like you can see it here, it is a cell which is been showing to us. This have this positive terminal and the negative terminal, and this positive terminal is called to be the higher potential one, higher potential, and this negative one called lower potential, is called lower potential. So what happened with the higher and lower? Just assume it just like a water tank which is being kept at the roof of our house. It's been filled, like suppose this is the water tank, and from here we connected some pipe which has been coming down, and then some tap has been there. Okay, and then the bucket has been, we have kept it. So if the water has been filled and it's been kept at a certain height h, because of the gravitational potential energy, see again, it is at higher potential, this tap is at lower potential. Because of the gravity potential energy, what will happen? When you turn on the tap, the water starts to come and flow it down. Simple. Similarly, as an analogy of it, similarly, the higher current, this charge which has been at the higher potential, starts to flow from this higher positive to negative, and that's what we say the current moves. That is the current, just a second. Yes. So this current I, okay, this current I moves from, that's called what? Convectional current. That's called what? Convectional current. This I moves from positive terminal to negative terminal. Positive to negative, that is higher to lower. Okay. If the current goes from positive to negative, obviously the electron will be going from negative to positive. As you can see, this blue color direction is been showing of the electrons, and this one is been showing of the positive protons. Because they both are making it, because they are having the charge. Neutron do not have any charge. It's a neutral. It has the mass. If in the paper it comes out of the in the atom, which thing is having the mass but do not have the charge? That is what? Neutron. That is the neutron. Okay. So one more analogy or one more things comes. It is mandatory and it is true that everything has the mass except the radiation one part. We'll talk in the light one part. Everything has the mass. Everything has the mass, whether it has charge or not. But if the body is having the charge, then it is compulsory to have the mass, like this one. This is electron and protons are there. They have the charge. That's okay. They have the mass also. Neutron do not have the charge, but it has the mass. Getting my point? Okay, so this point which you need to remember is proton, neutron, electron one part, which is the part of it. Then in the current in the circuit, current goes from higher potential to lower current. That is called convectional current. That is called, remember in the paper, for the paper, convectional current goes from positive to negative. Remember. Whereas when we talk about the electrons, electron goes from negative to positive. That is opposite to the direction of convectional current. I hope so it's been clear. And what's the function of the battery? It's providing the potential difference. That is potential difference we don't have V, and that is being work done per unit charge. Okay, clear? Now let's come to the symbol one part of it here. Just a second. Let's come to the symbol. How the symbols is being used to draw these parts? Very easy. See, like you can see here, what we have done for the cell. Suppose if we have the cell, see we have the cell here. Yes, this cell positive and negative. For this notation, for the notation, finding out that one part, we have a higher terminal, a long leg one, the part of it which we call as a long leg, and the short one and this is like called the higher potential, that is H dot P, and there is a negative, that is a lower potential. The short form I am writing it. You don't have to write it, you just write it with the positive and negative. Okay, so that's a cell. If we combine one or more cells together, that forms the battery, as you can see it here. So it's positive, negative, positive, negative, positive, negative, positive, negative. Done. So I hope so it's been clear. That's a battery and that's a cell. Okay. Then we have the connecting wire. Any wire which used to directly connect it. If you take the wire, connect it with the one terminal, like for example, if I have this as a bulb, okay, and this wire has been connected from here, and that's a cell I have been used. See, a very simple, without a switch, I made a very simple switch circuit without the switch, which has been, the current has been flowing from here I, and like this, and passing through the bulb, and it starts to glow. Whereas electrons are going like this, opposite to it. Simple diagram. No rocket science in this. It's a very easy one diagram. Okay, everyone. So I think this has been clear to you all. Clear? Then let's come to this. So these symbols are very important. Okay, so as you can see, so we have this battery, then cell, connecting or the conducting wire, basic one. Then we have this resistance. Now this type of resistance which you are seeing, it is called to be fixed resistance. As you go to the market, you buy the resistor, very small one, it comes with the color coding over it. Okay, in the senior classes or in the classes you are going to learn about the resistance with the color, and for that you have a very good thing for learning it. That's an okay, so we used to learn it, the color coding. You can find it by manually also without any instrument like the multimeter or something. Just by the name of B.V. Roy, Great Britain had a very good vibe, which you are going to learn. Okay guys, okay, so that's a fixed one. So sir, if it's a fixed, then what is the variable one? How it's been changing? Nothing you have to do. Just draw the circuit, just draw the like this only. Okay, just draw it like this only and put the arrow like this, and it shows as a variable resistor. I hope so it's been clear. It's a variable resistors. For this only we have one more thing that is called to be rheostat. That is also a variable only. For that we have the symbol like this, and one jockey over this. Only this one. This jockey used to move here and there. Okay, and that is all the variable one. I hope so it's been clear. If you any doubt, anything will be there, drop in the chat box. Okay. Then we have the bulb right now. Then we have open switch bulb and the closed switch, as you can see. Right now this terminal is not being closed. If I put it or press it like this, it will be closed like this, and it forms the closed switch. For the current to flow, we require the circuit needs to be closed. An open circuit won't pass the current through it. Okay, so this is the bulb, this is the open switch, closed switch. Then we have this one more device that is called what? That's called the ammeter. We come to it. Wait a second. We come to this ammeter, voltmeter and galvanometer. We come to it. Leave it for now. Just see the symbol of it. You put the A. See, because current also have the unit of ampere. Like current unit is ampere, denoted by A. Why denoted by the A and written by the small letter? Because it's the name of the scientist. It's the name of the scientist. Okay, so that is the name is Sir Andrew Mary Ampere. Okay, so that's A. Clear? So if we put it for the ammeter, just draw A, put the circle over it, and plus minus, that is the direction. Same with the voltmeter. The name of the scientist is Alessandro Voltas. So from here, then we can see one more thing. Switch is been this one, and this is a key. So if it's a closed key. If you see, it's a closed key. If I draw the open one, this is the open key. Okay, clear? Then you have this fuse. It's a working condition fuse. It's not been breaking one. Okay, if I just draw it like this, so this is the braked one. The high amount of the current flows through the wire, and due to which what happened, it's got braked, and the appliance from which it is being connected just saved it. It just saved that. Then you have one more device which stores the charge. It stored the charge, which you are going to learn further. Store the charge. That is called capacitor. Okay. So these are the things basically. And here we have the small and very easy circuit diagram in which you can see one bulb or the appliance. Instead of the bulb, you can just write one thing also, that is a load here. Then you have the source, a battery or something, or the cell. Then you have one key or a switch to turn it on and to turn it off. Simple, very easy one thing. Okay, so I hope so it's been the one which has been clear to you all. Okay, proton, neutron, then current flows from here. A proton is 1838 times heavier than the electrons. Okay, so these are the things. Now, when you have the circuit diagram, there are two things. One is the closed circuit, one is the open circuit. I told you, if there will be an open circuit like this one, current won't flow and the bulb won't glow. Simple. If the circuit is closed, then only the bulb will glow, or whatever the load of the appliance you are keeping it, that will work only when the circuit is being the closed one. Circuit is being the closed one. Do not ever do a correct if instead of this one it's been formed like this. If two parallel lines seems to be there, never ever correct as a part of the battery or it. It should be, one should be the longer, one should be the smaller one. Then only it shows the battery or the cell. So most of the times the question may comes, every circuit seems to be very correct. The minute difference was what? The symbol here. They will represent the one of the battery symbol with the parallel lines, and that you have to find and distinguish it. Okay. Then it's been, now that's coming to the part of the bulb here. What is the bulb? Simple thing. A filament has been used into it. Then the current passed through it. This filament starts to glow because of the high resistance. Because of the high resistance and very high melting point. Okay. So we use widely the tungsten. We use widely tungsten. Okay, we widely use the tungsten as a material in the, as a filament of the bulb, okay, and this is having very high resistance. Remember, it has high resistance and very high melting point. In the question it may comes, why we use the tungsten? Because of the high melting point and high resistance, and it do not get oxidized very easily. First, second, third thing, it do not get oxidized very easily, and that is why it has been evacuated in a glass chamber and filled with some inert gases. Okay, why it's been done? Because if it's been come into the contact with the oxygen, if you break this glass, the current will pass through it, it will glow, and then it will burn. The filament will burn because of the presence of the oxygen here. Okay, so this is the basic terminal things in the part of it. Then coming to the most part of it, that's what? Heating effect of it. Electric current shows the three effect. I told you, I think in the previous questions we were doing it, I told you, electric current shows the three effects basically. What are they? If I just write it down here, just a second. Yeah, see it here. Electric current shows three effects. Okay? Electric current shows three effects. And what are they? Chemical effect, magnetic effect, and the heating effect. So first one is the chemical effect of electric current, where when you take the electric current to the source of the battery and the part of it anode and cathode, that is a positive negative terminal only, okay, put it into the water, it will start to separate or segregate the H2 molecules separately and the O2 differently. So hydrogen separate, oxygen separate. That is the point called electrolysis. Then electroplating, all is the part of this chemical effect of electric current. That means when the current passes through some electrolyte solution, it starts to do some effect, and that's called chemical effect of electric current. Then we have heating effect. We have heating effect of electric current, just like the bulb, just like the heater, just like the toaster, just like the iron, we have the heating effect. When the current flows, because of the material having the high resistance, it won't let the electrons or the charge to move further, and it needs to apply more force, and due to which the more force will be applied, so what will happen? There will be more friction. A practical approach we can say, more friction, and more friction make it to what? Starts to glow it or make the heat more. Okay. Hi Rekha. Okay, so heating effect of electric current. Then we have the magnetic effect. This is the thing which has been seen by the Christian Hans Oersted. This is the part which has been in up to 12th it will go, remember. Okay, so Christian Hans Oersted had done this. What he has done, a current has been passed through the conductor, and he observed what? That conductor, the conducting wire starts to produce the magnetic field, and one of the magnetic compass which has been kept near it starts to show the deflection, and that deflection can only be seen in the two cases, and that is what? Either you change the position of it, or either you bring some external magnetic field or external magnet nearby it. He didn't done anything. He not even changed the position of the compass. He didn't even place any magnet nearby. What he has only done, he just turned on the switch, and what he observed, the current which is passing through the conductor starts to produce the magnetic field, and due to that field the compass starts to show the deflection. We'll come to it. Okay, it was just the session in which I have to give you the main points of it topic wise, so it will help you in the revision of it. Okay, so the three effects are chemical effect, okay, heating effect, and the magnetic effect of it. So this one is the magnetic heating effect of it, like you can see for the iron, for the toaster. Okay, then we have one more thing into it, and that is the part that's called the fuse and MCB and fuse. That is the MCB, that is miniature circuit breaker, and this one is the fuse, which have some glass and the ceramic coating and the metallic coating. One part has been goes from here, one is coming from here, connected in the series. These are having the electromagnetic springs and all, and the relay part into it. Okay, so only the part which is being required for here is the heating effect of current, and we have this formula which is being given by James Prescott Joules, and that is why in the senior classes, in the class 10, grade 10, you will learn that's also called Joules law of heating. That when the current passes through a certain type of the material, it starts to show the heating effect of it. That is H is equals to I square RT, where I is the current, R is the resistance, T is the time. Okay, although this formula has not been, but I told you for your understanding. So when a wire or device connected to a cell or battery for the long duration, you have seen it. You have put it your cell phone, you have kept the charger for a long period of time, and you see when you touch your charger, it seems to be what? It seems to be what? It seems to be become hotted. Yes, थोड़ा गर्म हो जाता है ना टच करने पे फोन वगैरह, ये सारे प्रॉब्लम उसी के हैं. आयरन तो उसी का एप्लीकेशन है, सिंपल. करंट पास करो, हीटिंग इफेक्ट की वजह से गर्म होगा, and we can use it for the ironing it. Same with the toaster. Okay, now if there is a chance of, this is the heating effect one. Why these devices have been added here? These are the protecting devices. These are the protecting devices. What protecting devices are these? What they basically do, when the current, you want to stop the current or excess current will go. Suppose you have bought a PS5, okay, for example, okay, and it required a very limited amount of current. Suddenly what happened? The fluctuation of current starts and very large amount pass through it. What will happen? Your PS5 will damage. Definitely. So what you will do, you will start using the MCB or the fuse. So when the excess current more than its rating will go, so what will happen? Either it break the circuit and break the fuse, so current won't go and your appliance will be saved, or either it will trip. This will trip. Trip means it goes down, so you need to put it up again so that the current can start to flow again. Okay, I hope this thing is being clear to you all. Okay, then you have this one part also called the magnetic effect, which I told you, simple. Okay, whenever you have the current has been passing through, like see, even this one, what I have done, I have taken the wire. You can make the electromagnet also at your home. Let's show the same thing. Take the iron nail. Okay, take the iron nail, take the copper wire and start winding over it, and then return it back. You will get the two wires connected with some switch or battery, and just directly connected from the battery, from a cell on battery only. Don't connect it directly into the AC supply, okay? Otherwise there will be a blast. Okay, so now this will become magnetized. When you just turn it on, what will happen? This thing will become, this hole will become magnetized, but the maximum magnetism will be shown here. This will become magnetized. How it's been possible? Because of this phenomena only. A current carrying wire introduces magnetic field in it. A current carrying wire introduces magnetic field in it. That is being given by Christian Hans Oersted, and that is also called the magnetic effect of electric current, and this has been widely used in many applications like electric motor and all. See, the crane system for lifting the devices and the heavy vehicles, then the electric motors and the generators, then the MRI machine. You must have seen the MRI machines. And one of the very big electromagnet in the world, we can say on the earth, is that is called LHC. Okay, you must have known about the Large Hadron Collider. It's a particle accelerator, okay, which has been using a very huge electromagnet on the base of the principle of this. When a current carrying conductor introduce the magnetic field in it, that is the LHC, called Large Hadron Collider, the particle accelerator. Because of this only we got to know about the God particles, the graviton only. Okay, so this is the part. Then we have this electric bell also working on the same thing. We have taken the electromagnet. See, when the electron flows, it starts to produce the magnet. That's called to be electromagnet. Very simple. So this is the armature, you can see. This is the striker. When you switch it on, the current will pass through it, and when the current pass through this electromagnet, it will start to produce the electromagnet. And suppose if it's been like this, it will start to attract like this, and once it attract like this, what will happen? This hammer, striker or the hammer, will hit the gong, a metal which is sonorous in nature, starts to hit it and make the sound. Very simple process. Okay, clear? So this we have done. Then the part which I told you, if you want to measure current, then you need to use the ammeter, and that to be in series connection, in a series. Okay, and the symbol will be like, suppose this is the load and this is the ammeter for here. Then if you want to measure the voltage, that is the potential difference. Okay, if you want to measure potential difference, or we can see voltage across the device, across the two ends of the terminal, then we use voltmeter, and that to be in parallel, or we also called it as shunt. So suppose this is our resistance R, so we will use this as in the parallel form. Got it? Okay, clear? I hope so. This much has been clear to everyone. Okay, now let's move to the next part of it. That is the motion and the time. Okay, so in the motion and the time, the very easy one part is that's the motion and rest. And we all know in this whole universe nothing is at rest. If you will say, no sir, I am sitting at home for the last 1 hour, or I'll be just sleeping, I've been at that rest from 1 hour, how you can say I'm at motion? See, everything is in the motion. Just we need to take the reference of it. For example, let's take an example. Suppose this is our earth. Okay, and right now you all are at your place, at your home, sitting in front of the table and chair. I am taking this class from the studio. Suppose this is the place, I am here, okay, and this is the place, suppose you all are here. We all are at the same position. From the class started from 4 to 5. We all are at the same position. Okay, no issues. If I just call someone, if I call your parents, what they will say? No, he didn't gone anywhere. Obviously, कोई कहीं नहीं गया है, वो यही बोलेंगे, बच्चा यहाँ बैठ के पढ़ रहा है, simple सी चीज़ है. But लेकिन, and similarly, if your parents want to confirm from the office, where is Sachin sir? They'll say, he is taking the class, he is in the class only. Both of them are rest, according to us. But suppose on moon, some alien is been there and watching us. Okay, so at 3, he found us, not 3, 4 or 3, whatever the time, he found us that we are at the position this one. After some time, as we know, earth is rotating. After some time, this position changes. Suppose, for example, I am taking it here, and this is being changes to here. So what this alien will say? No, they are telling lie. They all are telling lie, because what is happening now, the position of the sir is also changed and position of the student is also changed. So according to the alien who has been on the moon, is been changing. He is also moving. And don't say that he is not moving, he is also moving in the motion. Okay, but the thing is, its face has been stuck at one part. The moon face has been, only the one side has been stuck, and then it starts to rotate like this only. That's why it's been there. And when you see this, the mission moon was been there. If you watch the documentaries on something, and if you know about the news and all, you will know it. Okay, so this is the major part of it. So what is happening? Simple, nothing has been there. Before the position was A, now position is been B. With time, position of an body or an object changes, then called to be motion. And if it do not change, according to the reference frame, according to the observer, if your parents and office one is been on the observer, for them we are at rest, but for the person on the moon is been on motion. I hope so you have been just learning about this station one and the train one. Okay, so that's why I've given a different type of the example to all. Okay, so we have the motion, we have the rest, we have the time and everything. Then type of motions has been there. We have the rectilinear motion, we have circular motion, and we have the periodic motion. A straight line motion is called to be the rectilinear. A circular motion is called to be the circular motion. A periodic motion, a motion which repeats itself after every interval of time, just like a clock, just like the clock. It's a periodic. Then we have one more thing, and that's also been a part of it, that's called to be the oscillatory motion. That is the to and fro movement of a pendulum. We all know the swinging of the pendulum to and fro. Okay, from the main point. That is what. So basic things. Then speed, nothing. It's what? It's tell how faster the object or how slow the object moves. Then formula of the average speed which is being required for us is what? Total distance traveled. The numericals may come in the examination from these topics. So average speed is total distance traveled upon total time. This is the formula which we need to learn it. Okay, and instead of the speed, if they ask for average velocity, so it will be total displacement upon total time. Total displacement upon total time. What makes the difference behind them? Very important thing. If I start my journey from A, moved again to same point, A only, my average velocity will be 0, whereas if I talk about the average speed, it will not be 0. It will have some value. It will have some value. It won't be 0. Okay, so total distance will be 2 pi r divided by time, but here the total displacement is 0, so it has been not been there. Just remember this one part. If they are going to ask and the object comes to its same position, that is the initial and final point becomes same. Initial and final position becomes same then. Okay. So these are the things. Then we have to come one more part which is important, that is the uniform and non-uniform motion. You know it. Uniform and non-uniform. That object covers equal distance in equal interval of time. Nothing. Equal distance, equal interval of time. For example, after every 1 hour, I am covering how much? 10 kilometers, for example. Very faster. So what I am doing, I am going from A, and then I am covering first 10 kilometers in 1 hour, next 10 kilometers again in 1 hour, next 10 kilometers again in 1 hour, and the next 10 kilometers again in 1 hour. So how much the total time I have taken? 1, 2, 3 and 4, that is 4 hours. And the distance 1, 2, 3 and 4, that is 40 kilometers. So I have covered 40 kilometers in 4 hours basically. Now if I want to find out my average speed, that will be 40 divided by 4. That will be my average speed. But this type of the motion, that is the equal distance covering in equal interval of the time, that is called what? Uniform motion. Now instead of this, if I do what? If I cover first like 15 kilometers in 1 hour, then I cover see, time is an independent quantity. You cannot stop the time. So that's why I've been saying it 1 hour time period we have taken. But the distance that in next 1 hour, there's a very crowded area. So he covers only 5 kilometers. In the next 1 hour, he covers 10 kilometers only. And in the next 1 hour, how much he have done? He just moved again 2 kilometers, for example. This much. Okay, so 15, 5, 20, 30, 32 kilometers he have been traveled in 4 hours. But every time he has not done the same, he didn't cover the same thing. So this type of motion is called non-uniform, and this type of motion is called uniform. And for uniform or non-uniform, we have the graph, and that's also called DT graph. Basically, we say that is position time graph. So we always draw the time on the x-axis, and on y-axis we draw the distance. Suppose, okay, so for the uniform you always get the straight line like this, and that's tell us about the uniform motion. But for the case of this one, if we say that the distance and the time, if the graph is being like this, then it's a non-uniform or any curve of it. If it's not a straight line, non-uniform. It's a straight line, uniform. Simple. Equal distance, equal interval of time, done. Simple. Okay, now here you can see one thing, and that's the pendulum. Okay, that's the pendulum here. So let me just tell you one simple part of the pendulum very fast. In this pendulum, this length is being, you can see from the top of it until the bob, you can see the length of the wire is here, but we take the effective length of it. We take effective length of it. What is that effective length? From here to center of the bob, this is called bob. This metallic sphere is called bob. Okay, this metallic sphere is called bob, and this is the central point, that is the COG. For the sphere, the COG, that is center of gravity, the basic part is been at the center of it. So it's been at the center, still here. So you can see that's called the effective length L. And this point where it rests, see, if I just take my hand here like this, and that's the neutral, that is the mean point. And if I take it like this one, so it's raised to a certain height, and then I leave it, then it goes like this one. Okay, so like this it's been moving it, if you see. Okay, so that's the pendulum motion. Simple. That is to and fro. That's to and fro. So this movement from here to here, it goes. So that it rises to a certain height. It rises to a certain height. So at that point, it just stopped at there. So that's called to be its kinetic energy 0, and potential is the maximum. Okay, and it's done certain displacement. So if I go to number system, we go that is the positive x. That is the displacement. It's been done. And then in this direction if it goes, so in the negative x, that is also the displacement only, but in the negative direction. Okay, here also kinetic energy is 0, potential is maximum. But when it comes to the central point of it, it will have the potential energy 0 and kinetic is maximum. But due to certain external forces, what it will do, it goes like this, and slowly it will come to the rest. Simple. Okay, so these are the part of it for the pendulum. Then we have the graph. Then we have the graph of it, like the uniform, non-uniform. Okay, so here we are talking about the distance time graph, or we can say position time graph. We are talking about the position time graph. Okay, so in the position time graph, whenever you see the line which is being parallel to the time, a motion line which is seen to be here, and this becomes parallel to it, we can say one thing. What saying? Suppose this is like, for example, this is 0, this is 2, 4, and for example this is 6. Okay, so what has happened? This is 2 kilometers, for example, 4 and 6 kilometers. After 6 kilometers, the body is not going anywhere. It's not going anywhere. It's been just showing that time has been increasing. So because time is the independent quantity, it won't stop for anyone. So it will keep on increasing, but this line seems to be straight with that point of the fix at the 6 kilometers. That means object is at rest. Object is at rest. Then for the uniform, told you it's a straight line. For non-uniform it should be a curve. For non-uniform it should be a curve. Okay, similarly we have the many of the graphs like the VT graph, that is a velocity time graph also we have. So if in the velocity you can see like this is the velocity we draw, this is the time we show it here. If in the VT graph it's been like this, remember this is the confusing one part. If the graph changes to VT, it's not at rest, it seems to be it's at constant speed or the velocity is moving. Why? Because that's a velocity time graph and this is the speed time graph. Remember, because that's a slope. The slope of distance time graph gives you the speed and the slope of this gives you the acceleration. So here the acceleration is not changing, so it's moving with the constant speed. Suppose if this is like 0, this has been like 20 meter per second and this is at 40 meter per second. So the speed remains 40 meter per second throughout the time, it's not been changing yet. Okay, so these are the part of it. Now I hope so this much has been done. Let's talk about something for the light also. Let's talk about something for the light. See, I told you we'll cover most of the part, we'll cover one by one. Okay, so it will give you the revision of the topic also. Okay, why we are doing it? To getting the good marks. And what will happen with the good marks and the rank? You can see the scholarship will get of the 100% and the exciting gadgets. Okay, very exciting gadgets, and one of the most important, according to me, for me what I like it, that's the NASA trip. Okay everyone, so let's talk about the light. See, what is the light? The study of the light. Maybe the question comes, study of light. The study of light, just a second. Yes, study of light is called optics. Okay, it's called what? Optics. Study of light is called optics. Then if it's called optics, then what? Nothing. See, so the optics we have is of two parts in the optics. One is the ray optics, which is also called to be a geometrical optics or geometric optics. Okay, you must have seen in the books the ray diagram has been formed, yes or no? And for drawing that ray diagram you cannot draw it free-handed because you need to mark some points, and that's why it's called to be the geometric optics. Then we have the wave optics, which is not in the part of the syllabus for now, but I can just telling you it's a wave optics has been there. Then, so we all know light is what? Light is a transverse wave. Remember, light is a transverse wave. Light is a transverse wave. Light is a transverse wave. Okay, and it is a electromagnetic wave. That is EMW. That is electromagnetic wave. That's a electromagnetic wave. So what is light? Light is a transverse wave. Light is an electromagnetic wave, and it's a form of energy that causes the sensation of the vision. Obviously, if I just turn off all the lights in this, every light I turn it off, not even a single light has been coming, then what will happen? I won't be able to see, and even this camera who's been working as an eye won't able to take or capture the image. Simple. Unless it is a night vision camera. Okay, so light is what? Because of this light only we used to see the objects. Now for that phenomena we have the different part, that's called reflection. But who is responsible here? Light. Who is responsible here? Light. Okay, so light is what? Light is a transverse wave, it's an electromagnetic wave, and it's a form of energy, and it always goes in a straight line, and it always goes in a straight. See, there are the things in which the light bends. We are not talking about it right now. We are talking about the lights travel in the straight path. Lights travel in the straight path. So source of light are the natural sources. We have artificial, we have, then we have the luminous, and we have the non-luminous also. Okay, so I think you all know about these luminous and non-luminous. Like for example, if we talk about the sun, if we talk about the bulb, that is non-luminous. If we talk about the anything like the book, table, moon, these are what? Non-luminous. This shows the light because of the reflection from the source somewhere from getting it. Then natural is from the nature. Natural is from the nature. When there is a nuclear reaction happening in the sun because of the combination of that is called nuclear fusion. Hydrogen coming together, forming the hydrogen bomb reaction of it. Then converting into the helium. That is the whole process. That is a nuclear reaction, and it's giving the light in the form of it. Then electric bulb, the current which is being passed, this is the artificial. Why? When the current passes through this filament, it starts to we have read it in the starting one part only. Okay, so this is the filament. When red up, it's red hot glow and gives the light. So told you, a straight line or the path along which the light travels is called the ray, and when the group of light goes together, that called as a beam of light. Then this beam of light has been many, like the parallel, convergent, and the divergent. Simple. Parallel means like this. Okay. Convergent means, suppose this is the source and light is going, this is the source suppose, and the light has been coming like this towards it. So that's called converging. Everything has been going and converging at a point. Then divergent, same, only the rays will go outward now. That's the divergent from the source. That is the source. That's why what I've drawn the source here. Okay. So I think this much has been clear to everyone. Okay. So basically what the light. So in the light we used to see the two phenomena as optics. One part, that is the ray optics, and the ray optics we see. In the ray optics is being talked about, one is the reflection, then the refraction, okay, and then we have the dispersion. Okay, so we all know when the light goes from incident to reflected ray, what will happen? This is the angle I, this is the angle R. So according to the reflection law, angle I is equals to angle R. The incident ray, the normal, which is perpendicular. Remember this point, these are the important. When the light goes from the normal, it comes back from the normal. So here angle I is equals to angle R is equals to 0. But if it's been falling like making certain angle, and this angle always been formed with the normal itself, This is the mirror, that's a reflecting surface. From here we have polished it. From the back we have polished it, and this surface becomes the reflecting surface. This surface becomes reflecting surface. Okay, now if I want to find the deviation, I've done in the previous class also. If this ray, if there is no mirror, this incident ray must have gone like this in the straight path. But because of the reflection, that's the bouncing back of a light ray into the same medium, so what will happen? It's just moved this much angle and till come here. So that is called angle of deviation. That's called angle of deviation. So angle of deviation, that is del. So del plus angle I plus angle R is equals to 180 degree. Okay, so this you can solve it. I told you in the previous one classes we have solved this question. Okay, so this we have done. Then for the image, whatever the image we will get it, that is the image is the real image and the virtual image. The image which see right now which you are seeing it here now, that is the real image. Okay, and the image which you see in the mirror, that's a virtual image. Okay, this image is the real image because we are observing, we are seeing it on the screen. If something has been on the screen we see, it's called real. If something we are not getting on the screen, it's called to be the virtual. Simple as that. Okay, that's the real image and virtual. Now things to remember: real images are always inverted. That means if the object is being kept like A and B, so image will be formed like A dash B dash. That's called the inverted. Then virtual images are always erect, which is also called to be the upright. That means if the object is being formed A and B, so image will also be formed like A dash B dash only. Okay, then what else has been there, sir? More are there. Now, so this is the plane mirror and mirror. So now this mirror, if we talk about the mirror classified into two parts. One is called to be the plane mirror and one is called to be the spherical mirror. Okay, one is called to be the spherical mirror. And then this spherical mirror are further been classified into two parts, that is called the concave and convex. That's called spherical mirror, concave and convex. Concave mirror are converging. See the important points, I am going through it, okay? And the convex are diverging. Clear? Concave forms real and virtual both images, and convex forms only virtual image. Remember this part. Then when we talk about the plane mirror have certain properties. That is what it always, in the previous lecture I told you about this part, hai na? So it make the same size as an object, virtual and erect. Little inverted means I am showing my right hand to you and you are able to see the left hand, just you can see in the image. Okay, the right hand seems to be the left and left seems to be the right. The ambulance one example if given you in the previous session, image distance is equal to the object distance. Yes, if suppose this is the mirror, please go and check the previous questions. Okay guys, please check the previous question I have told about the plane mirror in the depth properly. So if the object is being suppose here at a distance x, so image formed will be at x only. So the distance between the object and image will be 2x. Size same, distance same, laterally inverted, left seems to be the right, right seems to be the left, and virtual and erect. Virtual and erect, told you. For the concave, converging, real and virtual images we get. Convex, diverging, only virtual images we get. Okay, basically if we go furthermore, it forms 6 ray diagrams, and for this we form only 2 ray diagrams. Okay, then the uses are widely comes in the papers. Concave, converging, 6 ray diagrams, 5 real, 1 virtual. So one of them is one dental mirrors for magnifying one. Then in the headlights, convex, in the rear view mirror, the back one which we used to see, and in the surveillance mirror. These all are the examples which you have seen in your daily life. There are many examples are there. Okay. Then when we move forward in the form of the dispersion one part, that's the most important one of the part of it, dispersion. You all see in the rainbow, and that is the reason is dispersion. That is splitting, that is breaking of the white light into 7 colors or its constant color. What are those 7 colors? These are vividure. These are vividure. 7 colors are vividure: violet, indigo, blue, green, yellow, orange, red. Now the question which can come from here: violet shows maximum deviation, it has least wavelength, and they scattered very fast. Okay, then as you go up, wavelength, which is also denoted by the sign called lambda. Okay, this is what it's in. What it do? It increases. It increases, or we can say for the red, wavelength is maximum. So if maximum wavelength, least deviation. Remember, least deviation. Okay, least deviation, and scattering is also less scattered. Remember, violet max deviation, violet max deviation, yes, least wavelength, scattered more instead of fast light more. Okay, whereas red maximum wavelength, so scattering is less and least deviation, and the least deviation. Sunlight, which is the white light which has been coming, when this white light split into the 7 parts, that's called what? When this white light split into the 7 colors, it's what? It's called dispersion. This is called dispersion. And guys, and one more thing, these 7 colors, arrangement of these 7 colors, let me write it down. Arrangement of these 7 colors according to their wavelength, tells what? It's called spectrum. Okay, that's spectrum. Okay, clear? So that is what the spectrum, the 7 colors arrangement is called what? That's a spectrum. Okay, so this is the what the Newton has also told it. Take the disc, you can also make the at home, then do the 7 colors and spin it very fast, you will see the white color of it. Okay, so guys, till here we have been studied. Okay, heat one part has been there, we will complete it in the other session also. Okay, I hope so things is being clear to you all. Okay, do let me know in the chat box what else you wanted for this one part. Okay, then in the next session we will be taking some part of it and then we are solving the questions. Okay, so that's for the session. I hope you have enjoyed it. We will do more question on it. Okay, so be there, we just put the notifications on. Do follow us on the Sri Chaitanya Education Institution on the YouTube, and just remember you are getting the very good things like the gadgets, 100% scholarship and exciting prices, and the thing is the what? The trip to the NASA. Okay, so please do like, comment, share and subscribe us. Okay, and the dates, most important dates, 28th of September and 12th of October is been important. We all know about it's a national scholarship examinations, everyone. Okay, so that's a very important one part. So and one of the session I made it for this score, and that is for the what? For the Olympiad also. So if you are preparing for Olympiad, and if you are just thinking for giving the Olympiad, that is the classes which has been giving you the very beneficial things. Okay, just dates are there. Timings has been there, 75 minutes for 6th and 7th, 120 for 8th and 11th. Okay, so guys, that's all for the today's session. I hope you have enjoyed the session. Okay, so bye everyone. We will meet again for the next session on the previous year question and the heat one part. Bye everyone.